Hey guys, welcome to my channel. A few days ago, just like any typical Persian, I was going through my daily routine. I'm drinking tea, staring at the wall, thinking about my messed up past and an even messier future. And suddenly, a divine revelation struck me. You need a new soldering iron. I mean, this old piece of trash which I have is not good anymore. The tip is worn out, temperature control does not exist, it's absolute dog shit. So like any normal human, I opened Google and started finding a good one, and I just remembered I'm not just some normal person. It's like I'm Persian.
Jesus loved everyone and wanted us to love all.
So instead of buying one, we make one ourselves. Yeah, I could buy one of those cheap ones from China, but no, my ambitions are bigger than that, and it's not fun to buy one. So I just start ordering some bunch of stuff. The main part is this Gordak handle, which you can easily find. It's not expensive, which is great. The handle itself isn't anything special. If you have a 3D printer, you can make one yourself. But since I already have this one, I'm just going to use it. Maybe in a future video, I'll make the handle myself. And this is Arduino Nano. Yes, I'm going to use Arduino because it's cheap and easy to use. Actually, it's make more sense to buy a Arduino Nano than buy the MAX6675 IC. For the voltage regulator, I'm going to use a 7805. Yes, it's cheap. And for the MOSFET, I'm using an IRLB4132. It's a logic level MOSFET, so if you're not using a logic level type, you'll need a MOSFET driver. First, I threw everything on a breadboard. If this thing doesn't work, we kind of score up. I know you guys have zero attention span, so I'm fast forwarding this part. I'll explain it super quickly for you. This side is the power section. Our input is 12 volts, and with the 7805, we convert it to 5 volts for the Arduino. And over here is the only brain in this entire video, the Arduino. This potentiometer works as a voltage divider, giving us a voltage between 0 and 5 volts. The Arduino reads that voltage and converts it into a PWM signal for our MOSFET. And MOSFET switches the heater on or off. If temp is too high, lower duty cycle. If is too cold, higher duty cycle. And that little resistor and diode just protecting the MOSFET. I'm going to use a tungsten lamp as my test load. And as you can see, the brightness of the lamp changes smoothly and continuously. And now, for the potentiometer. When I turn the knob, I get a value between 0 and 1023 on the serial monitor. That means the potentiometer is reading perfectly. If we connect the potentiometer together with the test load, in this case the lamp, we can already control the brightness of the lamp smoothly just by turning the knob. So everything is working great so far. The only thing left to do is replace this lamp with the actual soldering iron handle, and the station will be ready to use. Now, let me show you how much current the soldering iron actually draws. As you can see, when I adjust the potentiometer, the PWM duty cycle changes, and the current going to the soldering iron handle changes at the same time. One important thing to mention, right now, I'm running everything on a 12-volt adapter, which is a bit low. These soldering irons are designed for 24 volts, so the power will be limited with 12 volts. Unfortunately, I didn't have a 24-volt adapter available today, so I'm just using this one for the demonstration. Once I switch to 24 volts, it will heat up much faster. To read the temperature of the soldering iron, I'm using a MAX6675 SOIC-8, which is specifically designed for reading type K thermocouples. If you're also using a Gordak-style soldering iron handle, you'll need exactly the same MAX6675 chip. Almost all of those handles come with a built-in Type K thermocouple, so this is the perfect and most reliable way to measure the tip temperature accurately. I'm also going to add a small OLED display that communicates with the Arduino via I2C. This way we can see the set temperature and the actual tip temperature right on the screen in real time. But who the hell uses a final product on breadboard? I could have used Perfboard, but every time I do use it, it turns into a giant mess. So I went full pro, and I just designed a proper PCB in KiCad. Actually, it wasn't that fast. It was more like this.
This old lady loves DIY.
After finishing the PCB design, I wanted to order it, but I couldn't. Not because I'm Persian and don't want to spend money. You know, it's a bit more complicated than that. Long story short, I can't just click buy on Chinese PCB manufacturer like everyone else, so we're doing this the old school DIY way with the laser printer and the clothes iron. For the toner transfer method, I used a laser printer and printed the PCB layout mirrored on glossy photo paper. The print quality has to be really good, otherwise the result won't turn out nice. I also cleaned the copper surface of the board very well first. Then I used a regular clothes iron and pressed it firmly on top. To be honest, the first attempt didn't go well. The pressure wasn't even across the whole board, and the tape I had stuck on the edges was preventing good contact with the paper. So I put another sheet of plain paper on top to spread the pressure evenly. After a few minutes, I threw the still hot board straight into cold water. And as you can see, the toner transferred perfectly. For etching, I used ferric chloride. You're supposed to mix it with hot water to speed things up, but I completely forgot and used tap water instead. It still works, just takes a lot longer. After etching was done, I got too excited and started soldering the components right away. I forgot to cut the board to size first. I tried cutting it once with a cutter, but since it's fiberglass, I couldn't do it cleanly. So later I used a mini rotary tool, Dremel, to cut it properly. Once everything was finished, I wanted to make a nice enclosure for the soldering station. I even tried ordering a 3D printed case, but the price was crazy high. So I went the true DIY way. I took a PVC pipe, heated it up with a heat gun, flattened it, cut it, and somehow turned it into a box. It's definitely not pretty, but I glued everything together with super glue and hot glue. I'm using a heating element wire to bend the PVC sheet. Finally, I made holes for the OLED display. All the connectors, the power jack, and everything else. I put all the parts inside the box. here it is, officially the ugliest soldering station in the world. Actually, it kind of looks funny and cute at the same time. I'm in love with this little monster. Thank you so much for watching my video all the way to the end. All the files, schematics, code, and everything I used are in the description below. This was also my very first YouTube video ever, so it would mean the world to me if you could hit the like button and subscribe if you enjoyed it. See you in the next one. Bye.